Hi, my name is Raus from the virtual flight group 5Js, and I'd like to welcome you to a new tutorial about the GV5Js Datacard Generator. For those of you that still don't know it, this is a program developed with the idea of making the tasks of the DCS mission planners easier. Mainly used in multiplayer, although also suitable for single-player missions, it allows us to generate reference documentation to use during a flight. This means it generates the different data cards for the kneeboard that we would carry in the cockpit. And it does so in a format compatible with DCS kneeboard as well as with third-party applications. Personally, I've been using it for several flights together with VRK and a Wacom's graphics tablet, which allows me to have up to 2 virtual kneeboards that appear in the location we define, and over which we are able to take handwritten notes even while wearing a VR headset. Very handy to jot down coordinates or a 9-line brief. Okay, without further ado, let's detail the main features of the application and how to use it to generate all the associated data cards to a DCS Liberation generated mission with several human flights. Let's go. Commencing. When opening the application for the first time, you'll find it in this status. And here comes one of the latest features. For those that had used the program earlier, this new icon, left of the update check, offers two possible layouts. We can choose between a single panel layout, same as up to now, or a double panel that allows having two tabs visible at the same time. In addition to that, the tabs can now be dragged within their own panel or between the panels. Rearranging them in this way comes quite handy. For instance, to have one panel with a general tab and the other with the mission data card to see the effect of our changes in the generated outcome. Another remarkable new feature is the coalition selector. Before importing a mission file, we can choose if we are going to generate the data cards for the blue or the red faction. Well, let's start with a practical example, for which I have already prepared a mission file using DCS Liberation and saved it with the DCS Mission Editor. That's a recommendation from the Liberation developers and quite important given that there are some syntax differences between the .mis file created by DCS Liberation and the DCS standard, which could sometimes confuse the application. First step, load the mis file by one of three possible means: this button, the first icon in the list, or the File menu. Once loading is complete, the button won't be red any longer and we'll see the path to the file in this area. Next, we select our own flight for which we are generating the first mission data card. As you can see, the application tries to automatically fill in takeoff, recovery, and divert airfields. For that, it expects the last waypoint in the flight plan to be the divert field and the second to last to be the planned recovery field. Although they can be manually modified and the drop-downs offer all airfields from each map, if you would want to have them properly populated by default, I recommend checking that the flight plan follows this convention. In Liberation, this means you will have to delete the bullseye as the last waypoint. Then we can fill in down here the rest of the flights in the package. The Viper 1, 2, Tomcat 1, Cobra 1, Hornet 2. Here, by the way, you can see red is reserved for the AFAC or JTAC, blue is the AWACS, and orange are tankers. In my case, as we mainly fly multiplayer and there are plenty of human flights, I'm going to select only those, the human flights, as it's more useful to have them in the data card with their task, aircraft type, taken channel, and frequency. For the taken channels to be correctly assigned following our SOP, we have also to fill this human flights section in. This has two consequences. First, interflight frequencies are assigned for each of the flights, as we can see here in the Commcard. Wait a second. We fill all the flights in. And we drag the Commcard to the second panel. Here it's the interflight selection in the same order. Second, this selection determines the flight order into the package, and therefore the taken channels and the laser codes get assigned. Flight number 1, Viper, will have the 11X taken channel for the leader and 1511 laser code for the flight lead, while flight number 2 will use 21X and 1521 and so on. So in this case, Hornet 1 is the 5th flight in the package, meaning it gets the 51X taken for the flight lead and 1551 laser code. Before continuing with the mission data card, we are showing two interesting options. Overwrite miss file with GV5Js laser codes. This option modifies the mission file default laser codes and overwrites them with the codes already mentioned. I have checked this has effect for the F-16 and the Harrier, and those are exposing the laser codes in the mission file, but I am unaware of any other modules. The Commcard, overwrite mission file. Checking this option will overwrite the mission file frequencies for all human flights with the frequencies present in the Commcard when exporting it, be it through the Commcard export button or as part of a batch export in PNG or zip format. This way, all frequencies will already be set when stepping into the cockpit, and we won't need to manually input them. Quite handy. Timing options and other extras. This section. Startup time. This is the time assigned for a cold start on top of mission start time. So if the mission was starting at 7 o'clock and we have 20 minutes startup, we will end with a takeoff time of 7:20. Here you can see it. Basically, the app is adding this time on top of all waypoints. In addition to it, it tells us taxi time will be 10 minutes prior to takeoff. This might be a little excessive if we are taking off in a carrier or from a small airfield. So let's reduce it to 5 minutes and see how the taxi time is adjusted accordingly. Now, taxi time, it's 7:15. Last, 5 minutes before the taxi time, we have a reminder to perform radio checks. Now, station time. We can use up to 2 different station times. Normally, we are using them for holding patterns or refueling, but could as well be used to define a CAP station time, combat air patrol. Let's assume we've planned to refuel before joining the rest of the package on waypoint 2. We will modify the name of the waypoint to make it more evident. Now we'll assign 10 minutes station time on waypoint 2. And when we hit apply, this will add 10 minutes to the time over steer point of each waypoint after waypoint 2, meaning that the join waypoint was planned at 7:51. will now get shifted to 1 minute past 8 and subsequently. So I hit apply and there it is. We have still a second station time that we could use for a second air-to-air refueling or a second holding pattern, whatever we want to. Bingo and Joker. It uses a standard calculation, considering the distance between the farthest apart waypoint in the flight plan and the recovery field, and between the latter and the divert field, as well as an emergency reserve and a reserve for the pattern, landing pattern. We can also check options like a low-level egress, which is more fuel consuming, or instrumental conditions in the pattern, which will raise the pattern reserve. Joker is just calculated as so many pounds on top of bingo fuel. In this case, by default, it's 500. The calculated bingo fuel was 4,400, so we have a Joker of 4,900. MVG filter. This option applies a red or green filter per user preference to all exported data cards to avoid them being too bright and blinding us if we are flying at night. As a reminder of the option being checked, a colored frame will surround the previews. So if we select it, we might see a green or red frame. We will see what the final outcome is later on. Ramrod. This is a standard word for authentication, and per our squadron SOP, we have a standard word per day of the week. So if we select Friday, it would be Giant Lords. We have it here, but you can always manually modify it. And customization. So you can select your squadron logo or introduce a custom one. As you have seen, I've done it already. You just need to write the squadron name here, then click and select the image you want to use, and finally mark the radio button to apply. And then on all the previews, you already see the new logo. There it is. One section that we were missing from our walkthrough was the AI flights on the preset frequencies override. This has effect directly over the Commcard. So here we have the artificial intelligence controlled flights to be selected, or the support package. So we have all the AWACS in the mission, here only one. When we select it, it will go to channel 8 of the Commcard. We have the tankers, up to 3, in this case there are only 2, a boom and a basket one, that will go to channels from 13 to 15. And we have JTAC or AFAC flights to be selected here. So we have only one, which is the MQ9 Reaper, that will go to channel 16. This is the Commcard. We have previously populated the AI control flights. In addition to that, we might select the relevant airfields and carriers for the mission in these selector fields. Usually, we do this to generate a single Commcard for the whole strike package. In this case, we have flights taking off from 2 different carriers as well as from Larnaca and Incirlik air bases, and we are using Gesit-Kale as a divert field. So we select 2 different carriers, Incirlik, Larnaca, and Gesit-Kale air bases. If we would not like to select the airfields in this way, or just want to manually edit anything, we can disable the selector fields with this button up here. The lower section of the Commcard is just a collection of standard code words that we are using, but you can manually edit any of them. This is the coordination card. Here we can create a target area flow reference, combat air patrol patterns, or a VVR timeline reference. As you see, I've chosen to have mission data card and coordination card on screen at the same time. The reason is to show that timing data is cross-referenced between the two cards, and we can choose to introduce the time as we prefer. First step is to choose the flights to be shown. Again, we could be selecting AI-controlled flights, but as we are creating the documentation package for a multiplayer mission, I've just selected human flights exclusively. You may see that the only flight that does not get a time by default is our own flight, the one selected when we create the first data card. But this is not an issue, and the time used by the rest of the flights is just the takeoff time. So don't worry much about that. Now we have two options to assign the time. We can do it from the mission data card, manually writing it this way. So for Viper 1, let's say it will be from 7:40, to 7:50. And here it gets updated, 7:40 to 7:50. By default, all are using a vul time or vulnerability time, but we can modify it. And this is the only difference between making the input from the mission data card or from the coordination card. When we do it from the coordination card, using these buttons to edit each of the flights, we can select if we want it to be a combination of push and time over target or egress time, or a vulnerability time. So for Viper 2, let's choose this first option. And now we can modify and say that it will be from 7:35 push time and egress at 7:45. By the way, this flight plan displayed here is just to have a reference, even though the mission planner should have thought about this beforehand. This is a handy reference to know the timings of any particular flight. And it's taken into account this 20 minutes startup time that we applied at the beginning for our own flight. It's getting applied to each of the flights here. So when we close, we see that now Viper 2 gets updated from 7:35 to 7:45 as a push egress combination. And also one side effect when we update from here is that we get updated the name of the flights together with the icon of the aircraft type. If we would exclusively introduce the times from the mission data card, we should just hit the calculate button to get this very same result. So for the rest of the flights, let's just do it here as it will be faster for this presentation. 7:25 to 7:50, let's say 7:30 to 8 o'clock, and 7:40 to 7:50. And they got all updated here, except for Hornet 2 until I click out, and there it is, updated. If we want to create counter-rotating combat air patrol patterns, we can choose combining one pattern and the target area flow, or having two patterns using the layout selector here on top. It's worth mentioning that we could create a target area flow from here, from the coordination card, but then decide not to include it in the coordination card to be exported, replacing it by the second cap pattern, but we still have the timings For each cap pattern generated, we can choose the rotation direction, clockwise or counterclockwise, as well as the rest of the parameters. Mach number gets automatically updated when modifying the altitude, and it's also cross-referenced to the indicated airspeed. In addition to that, we can choose to generate the pattern with a defined distance between the hot and cold legs, leg separation, or just use a bank angle and let the program calculate the separation. Let's create two different cap patterns. Let's call this one cap Viper and this other cap Hornet. Let's say the Hornets will be on block 3, 30, Angel 30, Vipers, Angels 25. The Vipers are entering the pattern or the hot leg with a heading of 185, the Hornets on 220. The Vipers will be doing it at Mach 85, while the Hornets will be at Mach 0.8. And for the Vipers, we are going to use the bank angle of 40 degrees. For the Hornets, we are going to use a separation of 3 nautical miles between hot and cold leg. Calculate, calculate, and there they are. Last, the VVR timeline highlights the main VVR flow, decision, or action points, ranked by the distance to the enemy, and being a function of the altitude, block, and type of missile used by our adversary. So we can select enemy threat, AMRAAM, Charlie type, altitude block 4, calculate, and there it is. These are the notes cards. We have 3 different ones. First one, notes 1, is composed of an image, by default an AMSL authentication card, but can be changed just by clicking and selecting a different image. The text we can manually write on it and then select and apply different format options. Or we can, from the mission data card, select one of the waypoints, double click, and copy its coordinates. Important, we can, on the General tab, change the coordinates, let's say to grid. Then we export target coordinates, and then come back to General and select again whatever format we want to have on the mission data card. Okay. Can reapply the formats we want. Notes 2 is just a full page image that we normally use for the flight plan. And Notes 3, it's 2 different images that we might use, for instance, for surface-to-air threats. That's it. This is the pop-up calculator. It's not linked to the mission file, and we can use it to plan a low-level attack with a pop-up maneuver. We can choose to have an offset to the right or to the left and fill the rest of the parameters. So let's say ground speed 500 knots, altitude at the initial point 300 feet over the terrain, initial heading 175, altitude format MSL. This is important because on some planes, as the Hornet, above 5,000 feet, you don't have radio altimeter readings. Bomb type, conventional, low drag, minimum altitude over the target 150 feet. We will do a pop with 35 degrees of pitch, dive with 30 degrees, offset 30 degrees to the right, and 6 seconds to refine our aim. And the target elevation is 1,200 feet MSL, and the recovery will be at 3.5 Gs. Generate, and here there are all the parameters. We have mainly prepared everything and we are ready to export the data cards. So with that in mind, one last customization, you're able to write the name of the pilots participating in the mission here, so on. And you should go to the Navcards section. Here the theater is, or the scenario is selected by default based on the mission file, and it's already selecting Larnaca as it is our divert field. For the rest of the fields included here, you should just manually select them, and that's it. Checklists, as this is a Hornet flight, it selects F-18. If you don't want to, you can just select any other category. We have standard procedures, for instance, case 1 approach with a 9-line brief to use with VRK to take notes on top, and a blank notes card. Once we have everything prepared, we come here and select all that we would like to get exported. As we prepared one of each, we select all. You see that they get also selected here, and you could also deselect or select from here, and just click on export PNG images rather than a zip file. I prefer it. So I select the folder, export, and you see they get populated here. And you have the mission data card, comms, coordination, notes, pop-up, airport diagrams, case 1, 9-line, and blank notes. Now, if you want to export for the rest of the package, you just don't need to export everything again. Normally, you just generate a new mission data card for each flight. So I would select Viper 1. Now I don't need Viper Hornet. Okay. I had left it wrongly from my exercise before, but now it's fine. The airfields are automatically recognized. Everything's ready. You would write the name of the pilots on this flight. And just to show this feature that I mentioned before, I will apply the green MVG filter and click export here on the data card, save. And now you will see that we get a new file here for Viper. It's part of the export name, so to make it easier. And you look, it has the green MVG filter. And that's it. I hope you enjoyed this tutorial and you learned some new tricks to use with the application and that you find it useful. So if that's the case, please don't forget to subscribe to the channel and give a like to this video. I will try to generate more content in the future, maybe some deep dives on some other more obscure features that the program has and some upcoming features as well. Thank you very much. Stay safe. Bye.